Hello everyone, welcome to the video solution of Jan 25 Unit 2. Unit 2 is very repetitive. So what I've done is I've compiled all the most frequently asked questions as well as their answers into a PDF, and I've given the download link in the description below. You'll find it extremely useful as a preparation for your exams. So now let's get started with the video. The first question says, the formula for the current I in a conductor is I equals NQVA. Which of the following gives the meaning of N? So as you already know, N is the charge carrier density. And when you are asked to find out the density, it's always per unit volume or per unit area. So in this context, is the number of conduction electrons per unit volume. And per unit volume means in 1 meter cube of the material. So answer should be B. And you might be wondering what's wrong with D. D says total number of electrons in 1 meter cube. So guys, when you are dealing with a material, there are some atom bound electrons, right? Electrons orbiting the atoms, the nucleus, right? So these are not conduction electrons. Conduction electrons are the ones that carry the charge, right? So when you're dealing with charge carrier density, it's only the free delocalized electrons you're dealing with, not the atom bound electrons. So that's why D cannot be the answer. Question 2 says, there is a current I in a wire. The charge on an electron is E. Which of the following gives the number of electrons passing a point on the wire in time t? So for this, you can think of it this way. So charge of one electron is E, right? So charge of n number of electrons would be Ne. So you can also think of this as the total charge. So Ne is basically your Q, right, charge, and Q is given by IT. So you were asked to find out the number of electrons. So if you link these two parts of the equation, so Ne equals IT. Therefore, N should be IT by E. So IT by E, answer should be B. Now let's move on to the next question, that is 3. A car has a distance sensor that uses pulse echo technique to determine the distance between the car and the nearby object. The sensor emits a pulse of sound and then detects the echo after time t. The speed of sound is v. Which of the following gives the distance between the car and the object? So the moment you come across pulse echo, the equation that should pop up in your head is v equals 2d by t. Why do you have 2d here? Because the pulse travels twice the distance back and forth, the echo, right? So it travels a distance, it reflects back. So the distance traveled is twice d by the pulse. So you make d the subject of the equation. D would be equal to Vt divided by 2, which is the same thing as 0.5 Vt. Answer should be C. So when we were discussing question 4 in class, I saw most of my students found this a bit complicated. So let's see. Two waves on a string move towards each other at the same speed. Both waves have the same wavelength. The diagram shows the string when the waves are half a wavelength apart. So this distance is equal to half a wavelength. Now the question says, which of the following shows the string when both waves have moved a distance of half a wavelength? So let's pick half of the wavelength from each of the waves. So this is half a wavelength, and this is also half of a wavelength, right? So this wave would move this distance. Oh, sorry. This one would move over here, and this one should move half a wavelength over here. And check this out. they would overlap like this, meaning the two waves are in phase. And what happens when the two waves are in phase? They undergo constructive superposition. So at this specific position, you should get a constructive superposition, though, so the amplitude should build up. So the amplitude, the final resultant amplitude should be twice that of each displacement of the waves. So let's see. B looks promising. So the answer should be B, correct. So the problem with A is, for A, the waves have moved quarter of a wavelength. And this shows destructive superposition. We just saw the waves are in phase, so there's no way they'll undergo destructive superposition. It has to be constructive. And the amplitudes were downward, right? The displacements were downward. So the resultant displacement should also be downward from the equilibrium position. But D shows an upward resultant displacement. So this cannot be the answer either. Question 5 says, the circuit shown includes a thermistor. Which of the following explains the change in the ammeter reading as the temperature of the thermistor decreases? So focus on this bit, everybody. Temperature of the thermistor decreases. So we all know, as the temperature of thermistor decreases, the resistance increases. And why does the resistance increase? Because its conductivity decreases, right? So what ensures conductivity? Number of conduction electrons. So if the number of conduction electrons increases, conductivity would increase. If the number of conduction electrons decreases, conductivity should decrease, which would in turn increase the resistance, right? So to sum up, as the temperature decreases, resistance increases, conductivity decreases, so number of conduction electrons will also decrease. So the ammeter reading also decreases. Answer should be A. So our students found 6 quite challenging as well. So let's see. A student connects 3 identical resistors in the circuit as shown. So let's mark these. 3 identical meaning all 3 have the same resistance. When you deal with identical resistors, what they mean by identical is they have the same resistance. Next, the cell has an EMF and negligible internal resistance. Fine. Which of the following is equal to the reading on the voltmeter? Should also add, some of my students were a bit confused with the symbol of EMF. I heard a lot of students calling it EMF as in E. This is not E. This is epsilon. It's a Greek symbol, epsilon. It's not E. It's not a cursive E. Please remember that. Now the question says, which of the following is equal to the reading on the voltmeter? Right. So let's do something. We all know when resistors, identical resistors, are connected in parallel, the total resistance halves compared to an individual resistance. So right, if these two have resistances, individual resistances R and R, the total resistance, their total resistance should be, this entire part should have a resistance of R by 2. And just the opposite thing happens when it comes to series. Resistances add up, right? So this part, I don't have to cross it out like this. So the total resistance of this part is R by 2, right? Then the question says the voltmeter reading. So for this, you have to apply the concept of potential divider, right? So V corresponds to this resistance R. So the concept of potential divider is this R out of the total resistance, right? So the total resistance would be R plus R by 2. R plus R by 2 is 3 by 2 R. 3 by 2 R. So this is the ratio of the resistance, right? So this is the percentage of the resistance that R has out of the total resistance, right? And we all know potential difference is shared according to the ratio of resistance, right? So in this ratio, the EMF will be shared. So R and R cancels out. 1 divided by 3 by 2 is actually 2 by 3 epsilon. Answer should be C. So this is the concept of potential divider. Okay, the EMF is shared according to the ratio of resistance. Let's move on to the next question. 7 says, the diagram shows a wave of amplitude A on a string. P and Q are 2 points on the string. The wave on the string is a stationary wave. Very important point to address is it's a stationary wave. Which row of the table is correct? So guys, when you're dealing with a stationary wave, you have to identify this point and this point are my nodes, right? And you should know by now that particles between two adjacent nodes are always in phase. So P and Q are in phase. In fact, if there were some more particles, all of them, since they are all between two adjacent nodes, they would all be in phase. And when two particles are in phase, they have a phase difference of 0. But if you look at their amplitude, they have displacements smaller than A because this is an antinode and you always have maximum displacement at the antinode, right? So P and Q, neither of which are in the antinode position. So they'll have an amplitude smaller than A. Answer should be B because they have a phase difference 0 because they're in phase and their amplitudes must be less than A. 8 is another very challenging question. 8 says, a student used an ohmmeter to investigate the resistance of a uniform copper wire of length L as shown. The total length is L. The length T of the wire has resistance R. Which of the following gives the total resistance of the copper wire? So you have to find the resistance that corresponds to L, right? So you can apply this concept of length and resistance. I mean, the equation that links length and resistance, right? So the equation is resistance equals rho L by A. So since it's the same wire, it has the same resistivity, same cross-sectional area. So from here you can say that resistance is proportional to the length. I might be making it a bit complicated, but this is the best way you can relate to this question. So what we have established so far is resistance is proportional to the length. So this is an expression. If you want to turn this into an equation, it would be resistance equals to a constant times L. Take L on the other side. Resistance by length is a constant. What this means is the ratio of resistance to the length remains constant, meaning resistance 1 by length 1 should be equal to resistance 2 by length 2, right? So resistance 1 is R. That corresponds to this distance, this length D. So over here I write resistance by D should be equal to, I'm trying to find out the resistance, or in other words, total resistance. Let's call this RT. R2 would be RT, total resistance, and the total resistance corresponds to the total length, that is L. Now all you do is make RT the subject of the equation. RT equals R by D times L. And you can rearrange this a little bit as well. So RT equals to L by D, and R stays on the right, is the same thing. 2 times 3 and 3 times 2 are the same things. L by D times R, answer should be D. So all these just for 1 mark. So I always suggest my students never ever start from section A. Never be tempted to start from section A. Always start from section B. 9 is actually one of my favorite questions from this paper. Let's see. The diagram shows the energy needed for an electron in the ground state of a mercury atom to move to a different energy levels. A photon transfers 8.74 times 10 to the power minus 19 joule to electrons in the ground state. So let's say I have an electron over here. This is at the ground state. And here comes a photon with its energy of 8.74 times 10 to the power minus 19. So guys, the first thing you do is, this is the energy of the photon, right? So if you look at the energy level values, all of these are in EV, but the incoming photon has an energy in joule. So the very first thing you have to do is convert this energy in joule to EV. For that, what you do is just divide this value with 1.6 times 10 to the power minus 19. So 10 to the power minus 19 and 10 to the power minus 19 gets cancelled out. What you're left with is energy in EV is 8.74 divided by 1.6. The value is 5.46 EV, right? So from here, you can see you have an energy level of 5.46. So always remember, energy of the photon is always equal to the difference in energy levels. So this 5.46 will correspond to an energy level jump of this. The electron will jump over here. So this is not the ionized state, right? This is just a higher energy level. And when electron jumps up to a higher energy level, it will eventually drop down. And this is what you have to find out from this specific question. What are the ways it can drop down? So it can drop down directly to the ground state, but it can also drop down with an interim state. It can drop down to the first level and then to the next level, right? So this is transition 1, this is transition 2, this is transition 3. And whenever an electron drops down to a lower energy level, it always emits a photon. So there are 3 transitions which will correspond to 3 photons of 3 different energies and 3 different frequencies. So the question said, which of the following give the number of different frequencies? So you have 1, 2, and 3. Answer should be B. Question 10 is also quite complicated. So the question says, the reading on the voltmeter was 6 volt. So this is a load resistor, and the potential difference that you get across load resistors is what you call the terminal PD. You should know these terms. This is the terminal PD. And terminal PD is never equal to the EMF if the battery has an internal resistance. So the idea is, I hope you already know this by now, that EMF epsilon equals terminal PD V plus IR. Right? This is the base equation. And terminal PD is always V equals EMF minus IR. Right? So, but that's not what the question is looking for here. Question says, which of the following expressions gives the internal resistance in ohm of the battery? So guys, for this question, you have to recall the concept of potential divider again, which we saw in a previous question. So this EMF is actually shared among, so let's call the internal resistance. Let's denote this with small r, right? And the potential difference across small r would be, um, this is 6, and like we saw, EMF is always equal to V minus IR, right? So V is the terminal PD, so IR is actually the lost volt or the potential difference across the internal resistance. So IR should be EMF minus V, right? So EMF is 9 volt and lost volt, sorry, EMF is always equal to V plus IR, my bad. So this EMF is shared among the load resistance and the internal resistance, right? So you can write it this way as well, V across load resistance and V across internal resistance. So V across internal resistance should be EMF minus V across load resistance. So potential difference across internal resistance should be EMF is 9 volt minus voltage across load resistance is 6, 9 minus 6. We'll be needing this. That's why I did all of this. This will come in handy shortly. So now you need to apply the concept of potential difference again. So the PD across this is 9 minus 6, right? And for concepts like this, you have to recall this equation of potential divider. V1 by R1 equals to V2 by R2. This is a variant of the previous equation that we had seen in the previous question. So V1, let's consider V1 to be 6, and the resistance that corresponds to V1 is 10, right? Equals V2 should be this 9 minus 6 divided by R2 is the resistance that corresponds to 9 minus 6. You might be wondering, why are we not just writing, let's say 3? You'll see that in a while. So 9 minus 6 divided by R, right? So the question says, which of the following expressions gives the internal resistance? So make R the subject of the equation. R should be 10 comes over here, 10 times 9 minus 6 divided by 6. And they could have easily replaced 9 minus 6 with 3, but 3 was not in the option. That's why I went ahead with 9 minus 6. If you found this video useful and helpful, please consider subscribing to the channel so you can get updates to when I post the other videos. I will be uploading the rest of the videos for this paper shortly. Thanks for watching.